Okay, so today we're going to be looking at finding the inverse of a 3 by 3 matrix. Here I have a 3 by 3 matrix. You can take this theory and extend it further to find inverses of 4 by 4 and any other square matrix, but it does become very laborious very quickly, and in the exam you'll only ever be asked to find the inverse of a 3 by 3. So this matrix here is a numerical matrix. All the elements are numbers. So actually what we can do is we could just pop this straight into our calculator. So if you go into matrix mode, I can define a matrix, 3 rows, 3 columns, 4, 1, minus 2, 5, 7, minus 1, minus 2, minus 1, 1. So that's defined as matrix A. Push AC, option, recall matrix A, and inverse it. So it's this little inverse button here, minus 1, and it gives me the inverse matrix straight away. So the inverse matrix is 2, a third, 13 thirds, minus 1, 0, minus 2, 3, 2 thirds, 23 thirds. Okay, so that's the matrix I'm getting to. Now, the exam board know full well that you can take this calculator into the exam, so they tend to ask questions with an algebraic element in the matrix, so that you won't be able to use your calculator to find it. Okay, but if it is numerical, we should still carry out the method showing our workings, and then we can use the calculator as a check, not to give the answer. So what we're going to do is I'm going to create a table, and there are many different ways to find the inverse of a 3 by 3 matrix, but I like to do it this way. So the first column is called the element, the second column is called the determinant of the minor, the third column is called the cofactor, and then the fourth column is just a triangle, which is delta. And this is going to have 9 rows, and I'm going to split it up into 3 threes so that each row has its own kind of block. There we go. One table. Okay. We'll draw this up in the exam. And what we do is we take the elements of the matrix and we put them down in the element column. I tend to work in rows, so row 1 will go down here, row 2 will go down here, but you could work in columns as well. It'll give you the same answer. So I'm actually going to just do what I usually do and work in the rows. So it's the first row, 4, 1, minus 2. Second row, 5, 7, minus 1. Third row, minus 2, minus 1, 1. The second column then, the determinant of the minor. The minor is defined as being the determinant of the matrix when you delete the row and column of that element. So for example, this element here, number 4, if I delete the row that the number 4 is in and delete the column, I'm left with this 2 by 2 matrix, 7, minus 1, minus 1, 1, and the determinant of the minor is the determinant of that matrix, because that is the minor. And you can do the same thing for every element in this matrix. If I delete the column with the 1 in it and the column, the row with the 1 in it, I'm left with that 2 by 2 matrix, or that 2 by 2 matrix for the top right element. That 2 by 2 matrix for the middle element. Okay, you get the idea. So, the determinant of the minor of the number 4 is going to be 7 times 1 minus 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 1. So that's 6. Determinant of the minor of 1 is 5 times 1, which is 5, minus 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 2, so that's 3. Minus 2, we're going to get minus 5, minus minus 14 is 9. That's the first row. Second row, 1 minus 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 2 is minus 1. 7 is going to be 4 minus 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 4 is 0. Third one in this row, minus 4 minus minus 2 is, minus 4, yeah, minus minus 2 is minus 2. Bottom row, minus 1 minus minus 14 is 13. This one here, minus 4 minus minus 10 is 6. And then this one here, 28 minus 5 is 23. And that gives us all the determinants of the minors. Now, in this matrix, there is an invisible sign matrix that goes with it. And it starts with a plus in the top left, and then it works like a checkerboard all the way down. If you're doing 4 by 4, obviously you could just extend that, but the plus goes in the top left. And what this means is that every element that lies in a negative position, you change the sign of the cofactor. So it's going to be the middle element on the top row, which is this one here. The first and the last element of the middle row, so that's this one here and this one here. And then the middle element on the bottom row, this one here. And those 4 rows, we're just going to change the sign of the determinant of the minor and give us the cofactor. Those that are not on those 4 rows, the other 5 rows, will just remain the same. So that remains as a 6, because that's in a positive position. That changes to -3. That remains as a 9. That changes to +1. That's a 0 anyway. That changes to +2. That remains at 13. That changes to -6. And this one remains at 23. Okay. Now these were the rows of the matrix. So these will end up being the columns of the inverse. Before we go any further, I'm just going to check to make sure that the determinants agree. So to get the determinants in each section, we do the element times the cofactor and we sum them across the 3. Okay, and that will give us the determinant of the matrix. So I'm going to go into computation mode. 4 times 6 minus 1 times 3 minus 2 times 9 is 3. So this section here tells me the determinant of the matrix is 3. And if all 3 of these agree, then I can be fairly certain that all of this is correct and I can move on. Second one, I'm going to get 5 minus 2 is 3, because that's 0 there's not going to do anything. And then this bottom one here, I'm going to get minus 26 plus 6 minus 23 is, plus 23 is 3. Good. And there we go. So the determinants of the 3 sections agree, they are all 3. So that confirms to me that all the workings I've done are correct before I move on. So with this in mind, I can now state that the inverse of 4, 1, minus 2, 5, 7, minus 1, minus 2, minus 1, 1 is equal to a third. So we divide by the determinant, just as we do with the 2 by 2 matrix. And then what were the rows are now the columns. So I went across the top row, middle row, bottom row. So it's going to be left column, middle column, right column. And that's the answer. 6 minus 3, 9, 1, 0, 2, 13 minus 6, 23. And if you wanted to, you could bring that third in, but you don't have to. So that would be a 2, a third, a 13 thirds, a minus 1, a 0, a minus 2, a 3, 2 thirds, and 23 thirds, as we got in the calculator at the beginning of the question. Okay. So as I said at the beginning of the video, this question is unlikely to come up in an exam because it is a numerical matrix. So we're going to have a look at an algebraic one in this video as well, just so you can see the process. So it's actually the same situation, except now one of our elements is an unknown, it's a k. Okay, so we cannot put this into our calculator directly, and that's exactly why the exam board will do this. So element, determinant of the minor. Once you've done a few of these, you can actually leave out this column. Cofactor and det. And put them in 3s as before. This time the determinant is going to be a function of k, okay, a linear function of k. That's fine. We just have to make sure we state the value of k that the inverse does not exist for. Okay, so the element's going to go into the rows again, so minus 2, 6, k, 4, minus 11, minus 5, 1, minus 2, minus 1. And determinant of the minor. I'm going to get 11 minus 10 is 1. 6, I'm going to get minus 4 minus 5 is 1. And then the k, I'm going to get minus 8. Oh, sorry, itchy nose. Minus 8 minus 11 is 3. Element of 4. Minus 6 minus 2k. Oh, or minus minus 2k. So minus 6 plus 2k. The 11, I'm going to get 2 minus k. And then the minus 5, I'm going to get a 4 minus 6. Is minus 2. And the bottom row, I'm going to get minus 30 plus 11k. Minus 10, positive 10 minus 4k. And there's one down here, I'm going to get 22 subtract 24. Cofactors, we change the sign of every other row starting on the second row down. So it's these 4 elements. So that's 1, that goes to minus 1, that stays as 3, that goes to 6 minus 2k. That stays at 2 minus k, that's going to go to positive 2. That's going to stay at 11k minus 30. That's going to go to 4k minus 10. And that's going to remain at minus 2. And now we can calculate the determinant by doing element times cofactor. So minus 2, minus 6 is minus 8. So I get 3k minus 8. And they should all be the same, hopefully. So 4 times 6 is 24. Minus the 22, just in the constant first, plus 10, is 23, so it's not a good start. And then I get minus 8k plus 11k is indeed plus 3k. And then this one here, I'm going to get minus 30 plus 20 plus 2 is minus 8. And then the coefficient of k, I'm going to get 11 minus 8 is 3. So because these 3 don't match up, but the top and the bottom one do, that tells me that there's more than likely an error in this middle one, specifically with the constants. So I'm just going to check again the constants before I check the minors. So 4 times 6 is 24, minus 11 times 2, so it's minus 22, and then minus 10 gives me minus 8. Oh, it was just my calculator. That's my putting into the calculator a minute ago. 24 minus 22 plus 10. It's minus 10. There we go. I think I put plus 10 before. Okay. Right, now that those 3 agree, I'm happy that this is all correct. And now I can do exactly what I did before. These were the rows, so therefore these are going to be the columns. So I can state then that minus 2, 6k, 4, minus 11, minus 5, 1, minus 2, minus 1, to the minus 1 is equal to 3k minus 8 under, and these are going to be the columns. So 1 minus 1, 3, 6 minus 2k, 2 minus k, 2, 11k minus 30, 4k minus 10, and minus 2. And this is true for k not equal to 8/3. And you should state a value of k for which it is not equal to, because that is a value of k for when the determinant is 0, and hence this is singular and doesn't have an inverse, it doesn't exist. Okay, that's it.